Hi, welcome back. In this video, we're going to learn two tests using the first derivative that give us information about the graph of a function. The first test we're going to use is called the increasing-decreasing test. And so all it says is that if the first derivative of f is positive on the interval I, then that just means that f is increasing on that interval. And then if the first derivative of f is negative on the interval I, that just means that f is decreasing on I. The other test we're going to use is called the first derivative test, and that one is a test for local extreme values. So we test critical numbers. So let C be any critical number of f, and the test says if f prime changes from positive to negative at the number C, at the critical point, then f of C is a local maximum value of the function f. If f prime changes from negative to positive, that means that f is going down and then it's going back up at the point C, then f of C is a local minimum value. If f prime does not change sign at C, that means nothing interesting is going on there, then there's no local extreme value at all. It just happens to be a critical point. That's a really important thing to remember. All right, so let's see how to use these tests on a function. So let f of x be the function 6x to the fifth minus 4x to the third. We're going to find all the intervals of increase and decrease and all the local extrema. So the first thing we have to do is find the first derivative, f prime of x. Then we're going to use that to find all the critical numbers. Then we're going to use the increasing-decreasing test. We're going to test the intervals. We're going to use the critical numbers to break up the domain of the function and then test all the intervals. And then we're going to use the first derivative test to check for sign changes of the first derivative to figure out if we have local extreme values, what they are. First, the first derivative, it's a polynomial, so that's just going to be 30x to the fourth minus 120x squared. And I can factor that because I'm going to try to find the zeros. So it's 30x squared times x squared minus 4, which is just x plus 2 times x minus 2. So the critical numbers, remember, are all the numbers in the domain of the function for which the derivative doesn't exist or the derivative is 0. So our domain is all real numbers and the derivative is a polynomial. So there's no place where the derivative doesn't exist. So the only places where the derivative is 0 are at x equals 0 and x equals plus or minus 2. So there's 3 critical numbers. All right, so now we're going to check the intervals that, the subintervals of the domain. So there's going to be 3 subintervals. Using these, there's going to be 4 subintervals using these 3 critical numbers. We're going to have negative infinity up to negative 2, negative 2 to 0, 0 to positive 2, and positive 2 to positive infinity. And our first derivative, I factored it, we have 3 factors, so it's a little bit complicated. So instead of a sign diagram, instead of just a little number line, we're going to use a table, a sine table. It's a slightly more complicated derivative, so we make a table instead of a number line. So we're breaking up the domain into these little subintervals using the critical numbers. And then, so those are going to be my rows in my table, and my columns are going to be the factors of that first derivative. So the first factor is 30x squared, then we have x plus 2, and then x minus 2. So those are the rows and the columns. Now I'm going to add 2 more columns at the end because we're going to look at the signs of all of those factors, but what we need is the sign of the first derivative. So I'm going to add a column for the first derivative, and then the last column is going to be f, because I'll determine whether f is increasing or decreasing on each of those subintervals. So this is a sine table instead of a sine diagram. A sine diagram is a simple number line, and it's for simpler functions, simpler derivatives. All right, so now we're going to fill in the first three columns with pluses and minuses. So under 30x squared, notice that it doesn't matter what I plug in for x, that's always going to be a positive number because you're squaring x and multiplying it by a positive 30. So I'm just going to put pluses in that entire column. Let's look at x plus 2, the factor x plus 2, on the interval from negative infinity to negative 2. All we have to do is pick one number in that interval, like negative 3, plug it into the factor x plus 2, and we get negative 3 plus 2, which is a negative number. So that means that it's going to be negative on that entire interval. And then do the same thing for x minus 2. If I plug negative 3 into that, it's still going to be a negative number, so that one's going to be negative on that entire interval as well. So now we can figure out if f prime is positive or negative on the interval from negative infinity to negative 2. F prime is 30x squared times x plus 2 times x minus 2, so it's a positive times negative, which is positive. So f prime is positive on that entire interval. So now, since f prime is positive on the entire interval, that means the function f is increasing on the interval from negative infinity up to negative 2. So I'm going to put a little symbol there saying f is going up. I could write the word increasing too. All right, so let's look at the interval from negative 2 to 0. Pick a number in that interval. I'm going to pick negative 1. If I plug it into x plus 2, I get a positive number. So I'll put a plus there because it's x plus 2 is going to be positive on the entire interval. And then if I plug negative 1 into x minus 2, I get a negative number, so I'll put a minus sign there because x minus 2 will be negative on that entire interval. So now I have a positive times negative, so f prime is negative on that interval, which means that f is decreasing. All right, let's go to the interval 0 to 2. Plugging in positive 1 into x plus 2, I get a positive number, so there's a plus sign. If I plug positive 1 into x minus 2, I get a negative number. So f prime is a positive times negative, so f prime is going to be negative on that interval, which means f is still going down. All right, so now we're on the last interval from 2 to positive infinity. I'll pick positive 3, plug it into x plus 2, I get a positive number, so there's a plus sign. Plug it into x minus 2, I still get a positive number, so there's another plus sign. And then f prime is positive times positive, which is positive, so f is increasing. So now we've got our intervals of increase and decrease. So f is increasing on two intervals. It's increasing on negative infinity to negative 2, and then again from positive 2 to positive infinity. F is decreasing on two intervals. It's decreasing on negative 2 to 0, and then again from 0 to positive 2. Notice it's not decreasing at x equals 0. Why? Because the derivative is 0 there. The derivative is not negative and it's not positive. So it's neither increasing nor decreasing at the number x equals 0. So we've used the increase-decrease test. So now we're going to use the first derivative test. The first derivative test says, look at all your critical numbers. If the derivative changes sign at the critical number, then you have either a max or a min. So looking at the critical number negative 2, we see that the first derivative changes from positive to negative there. So f is going up and then going back down. So we have a local max And we have to find the y-coordinate because the y-coordinate is the maximum, the local maximum value. And so we plug -2 into the original function, 6x to the 5th minus 40x to the 3rd, and we get positive 128. Now, the next critical number was x equals 0. Notice that f prime does not change sign there. F prime is negative, and then 0, and then negative again. So it doesn't change sign at that critical number. So there's nothing happening there, nothing interesting. It's just a critical number. So then the other critical number that's left is positive 2, and we see that f prime changes from negative to positive at positive 2, which means f is going down and then coming back up. So we have a local min there. And the minimum value, the local minimum value, is f of positive 2, which is negative 128. So there's all the information we were looking for. We used a sine table instead of a sine diagram because we had 3 factors of the derivative that we had to test on 4 different subintervals. So a sine table was just a better way to organize our work. And we used 2 tests. We used the increasing decreasing test and the first derivative test. So that's how to use the first derivative to get information about a function. And in the next video, we'll see how to use the second derivative to get information about the graph of the function. I'll see you there.